start the recording.
Oh, okay. Can I start?
Okay. Yes, go ahead, Lai.
Okay, thanks, David, and hi everyone. This is Lai. So today I will be share a little bit of my career journey after my graduating from my PhD. I do have a fun fact. So at my year of my screening test, so both me and the other girl who won the two award for the apply and the theory, are in Meta right now. So both of us are like in Meta right now. So Meta is a really great place. So if anyone interested after graduating, feel free to reach out. Like we have a really good culture here. Okay, I will start my career journey sharing. So some like short background for me. My PhD experience in at USC. So I did my PhD in biostatistics at USC. Started my program in fall 2017 and joined County Lab around like October 2017. So I put my dissertation here. So my dissertation includes like two methods. The first method is to develop some like a hierarchical causal model to infer the pathway from exposure to outcome with summary data. So the summary data came from like the genetics data. So it's high dimensional data, and like the summary statistics is a set of like coefficients we get from the GWAS data. And the causal model here is actually a model from the causal inference. And the second project is actually to extend the hierarchical model to high-dimensional exposure data by integrating variable selection algorithms. So this is more like we have like the causal diagram, like from the instrumental variable to exposure to outcome. We increase the number of the middle variable, which is the exposure to high-dimensional data, and we use variable selection algorithm to select the one that actually causally relate to the outcome. So I attached my PhD defense deck here. So brought up a lot of memory of my PhD time when I put the slides together. So after these two projects and some side project like our package developing and some COVID project I did with David and Abigail, I graduated from USC in early 2021. And during my PhD, my last year at PhD, I did an internship at Facebook. So it is called Facebook by then. So I did internship at Facebook, and they gave me a written offer. So I just accepted and joined Facebook right after my PhD. So I attached my LinkedIn, yeah, like info here to show like my career progress at Meta. So I joined Meta as a data scientist, working on Facebook groups. So for whoever are still using Facebook, know that there is a groups tabs, and you can like form your own community, interact with other users, your friends or your neighbors on different Facebook groups. And that is a product I work with when I joined Facebook. So the major thing I worked in Facebook app is more on the product strategic understanding. So it's more like like we put together a data analysis or strategic analysis, and we collaborate with the engineer and the PM, which is like a product manager, to inform them like, okay, based on the data, this is the direction that we should go for next half. Or based on the data, we should kill this experiment because this doesn't help us at all. Or we should launch this experiment because this is helping us to increase our top line metric, like the user engagement, stuff like that. So that's basically what I did when I was at Facebook app as a data scientist. And then I got promoted. I started to work on a bigger scope project, which is embedded in the Facebook profiles. So if you have tried it out, it's actually like allows the Facebook users to create more than one profiles on Facebook. So that is has a higher technical complexity because you actually need to work on the user graph, and you need to solve like many data infra issues collaborating with your like cross-functional partners. So by there, I start to work on like in addition to the product strategy and the experiments, I started to work on some more technical part on the measurement plan, like how to actually map like those users to different profiles, building user graphs to help us do better recommendations, do better ranking on their newsfeed. So that's kind of the work I do when I was in like the profile. And I just want to add one thing on the experiments. So experiments is something I have done like all the time, no matter which team I'm in. So this is majorly help the eng team and the product team to understand whether their experiments is actually helping our platform to get better. For example, whether we are actually increasing our user retention, our user engagement or not. And another thing for the experiment, which I feel is more data scientist specific, is to help the team understand how they actually end up with improving the user engagement and the user retention, for example. And that will involve a lot of data analysis, like the funnel analysis, to identify the causal pathway. So I feel that is like the part I enjoy the most when I help the eng with their experiments. And then like I changed the team. I switched from the Facebook app to the ads org. So one thing I think really, really good about Meta is it has a really good like flexibility in org transition. So if you have stayed in like one team for long enough and you feel like, okay, it's time for me to get some new challenging, or you feel, okay, like I want to switch, I just want to switch focus because I don't enjoy the work I'm doing here, you can always reach out to the new team and ask for a team transfer. And so for me, after staying in Facebook app for like 1.5 years, I switched my team to the advertising org, which is like the help other Meta to get more money to increase their revenue. So switch from working on user problems, I start to work on the advertiser problems. So I continue to work as like the product strategy and also experiments as tech lead. And I also start to work on more complex modeling and the measurements work. Because one thing about advertiser is like when you work with the revenue, you know the revenue data is not like the data we usually deal with. It's highly skewed. Like very likely, I'm just making the number up because I cannot leak the number, but it's like you can assume it's like 60% advertisers, sorry, like 0.1% advertisers may actually contribute to like 17 or 80% of revenue. So it's a highly skewed data. So it encounters give us a lot of measurement challenging. And also like there are many like products like they actually want to leverage more advanced statistical models to improve their products such as ranking and like recommendation. So that where my technical background came in. And that is actually, I think, one of the main reason I got promoted again. So I started to involved in more like statistical savvy projects. Like I'm like become like the subject matter expert on causal inference. So if you recall, the reason I introduced my PhD dissertation is mainly because that dissertation actually includes a lot of causal inference model inside. So that is where I started to apply my PhD like knowledge into my like daily projects at Meta. Like I start to like promoting, okay, we should use causal inference when the experiment is not feasible. And I kind of like audit and summarize on what a scenario like experiment is not available, but we do need to measure like the revenue we care about. So start to promoting causal inference and more like building my personal brand around the company. So like people know, oh, if there is a causal inference question, I should ask Lai about it. So that's how I became like the subject matter expert on the causal inference and building my personal brand. And they also know that okay, like with this PhD background, like she is really good at statistics. So if there's any statistical challenge project, we should involve Lai as well. So they then like a more technical project came to me like on the experimentation. I also work work on a method development. Now, on top of the data analysis, I start to actually building model to solve some experimental challenges. So the one project I worked on is called bipartite experimentation. It's more like on the advertiser graph. So if you are an advertiser on Facebook, you can have many IDs. If you are a business, you can have your business ID. If you are a user, you can have your user ID. If you are an advertiser, you can have like advertiser account ID. So those ID interact with each other, and it's not available like for a single experiment to run on different ID grains. So we definitely need a method to tackle this question. So when a user has a set of very different IDs, but we can only run the experiment on one ID grain, how we can solve the measurement problem. And that's where we come up with like the bipartite experimentation. It's again like very close to the causal inference because it has this inverse probability weighting concept embedded, integrated with the paragraph and the counterfactual effect, like by using this graph and this IPW factor to actually weight those effect to get the estimate. So that's kind of like my work focus recently, like more on the causal inference experimentation. And I just joined another product team within as org. So I'm also like tackling all the product strategy and experimentation for that team right now. So that's kind of like brief journey I did where I'm at Meta. So one thing I promise I will talk in deep is more how I connect my PhD work to my Meta signature work. As I mentioned, like revenue is a highly skewed data. It's very challenging to measure in the experiments due to the high variance. Like imagine only 0.1% actually contribute to 60 or 70% of revenue. Again, the number is made up. So one solution we came up with is to say, okay, since we cannot measure revenue in some like experiments, can we actually find a proxy metric which can have less volatility, but is actually also causally connected to the revenue and treat it as a revenue surrogate in the experiment. So that will be a solution, right? But the question is then how can we identify such proxy metric? Then we need a framework to enable different teams to identify their proxy metric with like a solid statistical framework. So I put the causal diagram here. The diagram will be like the experiment assignment will lead to this proxy metric and then will lead to revenue. So in the ideal outcome from this project is, even though we cannot see any statistical movement on revenue experiment, as long as we are confident this proxy metric causally related to revenue and this proxy metric moves the experiment, we can make a launch decision for our experiment because we believe in the long run this metric can drive revenue. So this is where my PhD thesis kick in. So remember, I did this hierarchical causal model to infer the causal pathway from exposure to outcome with summary data. This hierarchical causal model, as I mentioned before, is actually a structure model based on the for the instrumental variable analysis. So this is a slide I adapted from my PhD dissertation. You can see the causal diagram here is actually very similar to what we are trying to tackle for the meta measurement problem. So the IV here is actually can be the experiment assignment because it's randomly assigned. It's the only variable that called revenue through the proxy metric in the experiment. And the X here is actually the proxy metric, and the Y here is actually the revenue. So this this scenario is a perfect application of this method. So I went back to my PhD dissertation. I studied my PhD dissertation again, and I came up with a proposal with instrumental variable analysis to actually build up the framework. So this is actually one of my signature work when I got promoted from senior to staff, and it got a really, really good outcome, really positive feedback from the leadership. They really like it because it's simple and elegant, but it also have like the statistical evidence in this is working. There are still many unsolved things. It's like how can you be sure this experiment can only impact revenue through this proxy metric? That's still something we're trying to figure out. We need to design specific experiments to satisfy this metrics. So there's still a long way to go, but at the start point, my dissertation helped me a lot in set up like this signature project, which is benefit my promotion. I think I only have 20 minutes, and I feel that's a good time check. Now it's 12:20, so I will stop here and take any questions you guys might have.
No, thank you, Lai. I I have some questions just that have come to mind there. You answered my major one, which was going to be how did your PhD work sort of connect to what you're doing now? Um, I guess, just going back, you mentioned that you did get an internship uh, to get kind of start your journey off. How did you go about getting that internship initially?
Oh, I probably don't need to share my screen, so
Yeah.
I just cut it. So I feel like the connection is super important. So I got my friend to refer me to the internship position, and I got the interview and did 2 rounds of the interview and just get in the in the program. Yeah.
So networking was very important for
Yeah,
that.
I feel
Okay.
yeah, networking is very important, and just to know, I think that's also like maybe one of the motivation why we have this alumni talk. If you guys want to like apply for Meta, feel free to reach out to me on the LinkedIn.
Yeah. It, you know, I guess following up on some of the other slides that came to mind is what sort of are the tools that you work in or the environment from a data science point of view? Are you still working in our studio? What about large data?
Mm,
How does the whole system work within Meta, you know,
mm, mm.
that environment?
You will find it's super interesting. Like not many people use R at Meta, but if a
So
person, like if a data scientist use R in Meta, this person definitely has like a statistical PhD or biostats PhD. It's very funny. So I think like most people at Meta work with SQL and Python. I still use R because that's this language I'm most comfortable with, and I love ggplot. I feel it make much better chart than Python. That's just my personal preference. So, but when it comes to very large data, either R or Python is not that friendly because you need to read the data in the environment before you actually run analysis on the data. So, if for some really simple analysis with large data, we always use SQL. I would say 70% of my time I actually use SQL. But if you are really needs to like do modeling stuff, like I will always use Python because Python kind of like much faster in terms of like modeling and the data tr model training. And for like chart, like for presentation and for like data analysis, I will use R because I just love ggplot.
nice. So is there anything that you wish you had learned in your PhD that would be really helpful?
Oh, that's a great question. I haven't thought about it. Um, I feel, I feel it's just to get to know more about your peers' work. That will be something I wish I have learned more. I do know like the some of my friends' work when I was at PhD, but I feel like if I can know more about what other PhDs are doing, like because I'm in biostat, but I feel like if I can learn more on the epi side, the health behavior side, maybe I can get understand more like how to actually present the data in like the applied analysis. So I feel that could in long run benefit our like the soft skills in the presentation, communication, stuff like that.
Great. Any questions from the audience? I can't see hands up, so any questions? Those on Zoom?
Yeah, how much do you make?
Sorry?
Yeah, Stan wants to know the salaries at Meta.
You can
Uh,
check the level FYI. So just the Google level FYI and check different job subscriptions levels. I feel they are quite close to the median average number.
yeah. Bonnie, you have a question?
Yeah, thank you for the informative presentation. Really learned more about like our future like a study gonna focus on in terms of our future career. So I just wondering like when would be the best timeline for preparing either internship or starting a new job?
That's a great question. I feel like if you are in PhD program, that is definitely a topic you can discuss with your advisor. So then in that way, you guys can plan your PhD program really well to make sure like you can deliver like your thesis. And the second suggestion is like I feel maybe if you want to get into the full time by getting a return offer, the last year might be the best because in that way, when you actually receive a return offer, you can join the company after your graduation. But in order like to prepare your internship, I do feel like the interview may take around like 1 to 2 months to prepare because you will not only apply for one internship, you may actually apply many internships, some in tech, some in biopharma, and some in other companies financial companies, things like that. So I feel like for different type of companies, even for the same type of company but different company, you have to like target their like company culture, their interview style. So you may want to like prepare them one by one. So that will take time. So I would suggest at least 2 months earlier before like you actually start to do those interviews. And also, I feel building resume takes time as well because you need to actually tailor your resume for some position to make sure like they can say you are actually a good fit. So for that part, I feel this is a should be a continual work you did like all the time.
Great, thank you.
Thank you.
It,
Find my earlier question. Uh, what about, do you see, how do you see sort of diversity and equity at, at places like Meta?
Sorry, I didn't capture the question.
Diversity and equity and inclusion.
Of the workforce?
Yeah, is the,
That
is
that
it, is it a friendly place for everyone?
Oh, okay. Yeah, thanks for the question. I do feel so. I know many people are not saying good things about the man working culture, but I do enjoy my work there. I feel like at least from my personal experience, my manager, my skip, and my colleagues are all very supportive, and they are also all very advocate for my career growth. So at least from my personal experience, I do feel it's a really friendly working environment.
Thank
great.
you.
Carmen, last question and we'll move on to Ying.
Hi, Lai. Thank you so much for the talk. This is Carmen. Thank you for taking the time during the workday to give us this talk. I have one question is that is there like any challenges, for example, like when you interview for the internship position or like full-time job position, do you have any like challenges in terms of like transitioning from academia to industry? For example, like I interned at Farmer during these past summers, and I found it the business aspect is actually quite challenging for me. And yeah, because you also like work on a lot of the revenue and using the process matrix, that kind of thing. Did you like find anything challenges, and how did you like address those?
Mhm. Yeah. Yeah, that's a great question. Thanks, Carmen. I think for me, there's definitely a challenge to change your mindset from like academia person to a business person. And you will like the feedback I got when I was junior is more like you don't have to do this 100% perfect. 60 to 70% perfect is good enough. The most important thing after you wrap up the analysis is to how you present your analysis, is how you can actually get the business recommendation from the data that you put together, like how to tell a story with the data that you have. I feel that is the part I struggle the most when I first joined the tech company, because I feel like in academia it's very straightforward in most of cases, and we have a very like high bar. And I'm not saying we don't have a high bar at Meta, but like we're having like we will iterate analysis a lot many times before we actually send to the peer review to publish the paper, and we will get many feedback. But when you enter a business board, you will find most likely people just trust your data, like just because you are the data person. So you have to hold yourself accountable for all the data you have, and you need to get those business insights from the data you have. Like when you only have like academia experience, from at least for me, I found it's super challenging how to balance like those like 60 to 100% perfection versus the business outcome I actually getting from the data. How much time should I spend on the TLDR part, which is getting the business recommendation? How much time should I spend in like polishing the data analysis to make sure it's like 100% perfect? That is like the balance I have been struggle with in my like internship as well as my early career at Meta. I think when you get more senior, this gets better and better, but again, it still takes a lot of time and a lot of effort to do that.
Great. Thank you very much, Lai.
Thank you for having me.
Everybody, if we could thank Lai for that was great.
Thank you.
Okay. We'll move on to Ying. I already did a brief introduction, but she was here in 2016 with graduated PhD and then went off to LinkedIn. And so without further delay, Ying, it's all you.
Thanks, Dave, and thank you, Lai, for the enlightening talk. I also find a lot of commonalities in our career paths, joining a tech firm as a data scientist. So thanks, Dave, for inviting me here. Can everyone see my screen? I'm sharing my screen on Zoom.
Yes, we can.
Okay, perfect. So yeah, everyone's career journey is unique, and I'm happy to share mine. Like Dave introduced, I joined USC in 2010. Let me see how I can move my slide. Okay. Yeah, so I joined USC in 2010 as a PhD student in biostatistics. I was actually initially admitted into the PIPS program. I did 3 rotations and choose biostats as my research focus. Apparently, that was a great decision. I really enjoyed my time here working with Dave, with Dr. Chris Hyman, Dr. Daniel Stram, and many other great professors. My research here was on cancer genetics. So I use human genomics data to build statistical models and run analysis to identify new and fine map those existing genetic loci that are associated with prostate cancer. So basically, I did my first try in the industry as a summer intern in a startup company called Zest Finance. It was a company on the Hollywood street. It has a small orange store, which is very hidden. I almost missed it on my first day there. How I got into that internship was also through a connection. One of my friends at UCLA was doing a full-time job there, and she introduced me to this intern opportunity. That was a year before my graduation. And during that summer, I was building out machine learning models for the company who is in the financial technology area. They're offering loans to consumers with not so stunning FICO score. And those are the clients that will usually got rejected by traditional banking services when they apply for a loan. And Zest Finance offer those loans to those customers in a smart way by using machine learning models to understand who will be likely to pay back the loan And if their loan got default for some reason, how likely they're going to repay if we call them through the customer service. So the latter part is called collections. And I was helping them to build one of the first collection models, which was later A/B tested and integrated into their products. Through that internship, I do find, okay, this is interesting. I like doing modeling work. I like machine learning. I wanted to continue to pursue a career in this track. So I was looking for a full-time job after graduation. I got into LinkedIn as a senior data scientist first, and later transitioned into a machine learning engineer. I'll share more details in the next slide. So I spent almost 8 years at LinkedIn. Starting from next Monday, I will be joining Google again as a machine learning engineer in the YouTube AI department. If you find anything, have any ideas or any complaints about YouTube ranking, let's chat. I'm happy to learn more from your experience as a user. So zooming into as I reflected on this career journey, I was asking myself, what is the common thing that drive me through those transformations from academia to industry, from intern in fintech to a social media platform, and later to Google, again, a social media platform, YouTube. I found one thing that is common and underneath all of those things and motivates me to continue take on new challenges, and that is using data to create value. For research, that is the value of finding new things for the research community. And for the business, that is the value that using data to create and drive business decision making or building models that powers those AI-driven products, and that creates value for the business and the users. So zooming into my LinkedIn years, like I mentioned, I spent 7 years and 10 months at LinkedIn. The first 3 years as a data scientist in product analytics. That has a lot of commonality with what Lai just shared. It's like using data to derive insights, running experiments, helping with product strategy, etc. So I wouldn't repeat that again. I'll share more about my transition in 2019, becoming a machine learning engineer. I really enjoy the work doing things end-to-end modeling, starting from designing the model, collecting data, training model, evaluating the model, integrating into the product, and launching A/B tests myself. I found that journey pretty rewarding and also super engaging. I like doing all those coding stuff. So I've been working on recommendation systems since then in 2019. I've launched models in linking feed and notifications, and I got promoted into a tech lead in 2020. My role also shifted a little bit after that. I have more responsibility, basically, be directly responsible for the project success, and also mentoring and guiding junior, senior engineers working with me on larger scope projects, managing partners, stakeholders, collaborating with other teams cross-functionally, and then definitely spending more time in meetings, which is not something I enjoy a lot. I still try to carve out time for myself to do hands-on work. But again, after working on recommendation system for several years, I decided to take on a new challenge in responsible AI, and that is working on AI fairness. If you have heard about recommendation system and different profiles or jobs get ranked differently, and that got personalized for each user, the AI fairness is basically tackling how can we make sure we are using those ranking systems and making them serve equally well to different populations of our user base. So that has a lot to do with statistics on measurement, mitigation, etc. I'll touch upon that in the next slide or so. And later on in 2022, I wanted to expand my knowledge space and learn about how to tackle unstructured data in machine learning, basically text data. So I took a course at Stanford learning about natural language processing and deep learning. And later on, after I complete that course, which is a pure coincidence, ChatGPT become so popular for many people in the world, and many tech firms are also investing heavily in building out or fine-tuning open source large language models for their own product use cases. So I got the opportunity to start working on large language models starting from 2023, basically fine-tuning large language models, the encoder part for linking domain-specific tasks like search ranking, content classification, and those fine-tuning make those encoders fit better in the professional context for text understanding. So let me share two projects which I feel are super, super related to my work in biostats. The first one is this project called Driver Analysis Framework. So this is a project which I tackle on in the data science team. You can imagine some common questions a business leadership will ask would be, what is driving our user to open the app again on the next day? And the reason I call it a framework is because the desired outcome can be quite different from time to time. It could be what drives them to apply for a job, or drives them to subscribe to a premium membership, etc. So just using this example, the way I designed the solution was done in 3 steps. First, collecting the data. Step 2, building the model. And step 3, interpreting the results. So for collecting the data, it is 3 things that we care about. One is the desired outcome. And second is the drivers of interest. What are the potential drivers? For example, viewing some posts, opening some profiles, or sending some messages. And also the potential confounders. It could be the user's geolocation, their industry, their job seeking premium status, etc. And as I list these things out, you might find it familiar. This is very similar to our genome-wide association study, where we have the outcome, which is a disease status. The driver of interest will be many, many different SNPs, the genetic mutations, and also the potential confounders can be many other health-related status. So for building the model, this is one model that I built, which is a classic traditional logistic regression model, where we model both the drivers of interest and the confounders into the model. And then after fitting the model, we can interpret the results. We first filter the drivers of interest by the p-value. We only take out the significant ones. And then the interpretation will be derived based on the beta coefficient and also the baseline probability of having the desired outcome with among users without the driver of interest. So basically, the interpretation is also very similar to how we interpret a GWAS result. So yeah, this is one thing that I feel I directly apply what I learned in my research into my work in the tech firm. Another project I'd like to share is under responsible AI area. This is a project I tackled in maybe 2022. So it's about model calibration. The context of a question is basically when we're building a ranking system, sometimes the ranking scores are not always perfectly calibrated. And there are some differentiation between groups of users. I'm using a mock example because I cannot share the real data. The mock example shows the dotted line is a perfectly calibrated prediction, and the blue can be one group, the green line is another group. And those curves are telling us, hey, we're over predicting the score for some of the blue users and under predicting for the rest. We're doing the opposite way for the green group. And how can we make sure we are able to correct those over under prediction for different groups in different buckets? And the goal of doing that is basically ensuring our recommendation system is serving different users equally well. The challenge here is most of the time in real application, we do not have access to the group information. This can be a real constraint due to legal requirement, due to regulatory policy. but we still want to do the mitigation. How do we do that? I did some literature research and found 2 papers which are published in Berkeley lab in 2017, 2018-ish. One is called multi-accuracy and the other is called multi-calibration. So for the sake of the time, I won't go into the details of the algorithm, but basically I was borrowing ideas from academia and using my biostats knowledge to identify what are the promising methodology we can borrow from academia and how can we prototype it, make some modification to it, scale it to accommodate our large-scale production data, and also prove the effectiveness of those methods in our real use case at LinkedIn. So this is a project which I demonstrated through this calibration method without access to sensitive attributes. We can still mitigate the bias to a large degree without really compromising on the overall model performance. So this is another project which I feel is very interesting and super related to biostats. And to summarize, as I reflected on this journey, how biostats has helped me in my career growth, I would like to share it from 3 different aspects. One is on the theory part, the coursework, the research, reading papers, those really sets a good foundation. And second is on the hands-on practice. I did a lot of coding in my research time at USC. Although those coding languages may vary from time to time, but there are some common philosophies on how you design the code, how you make the code modularized, reusable, easy to iterate. Those philosophies still carries on in my day-to-day work. And also running those analysis, building models on large scale, on high dimensional data, and presenting the results. The last thing but not least is the mindset. I think Lai also touched upon that. I feel my PhD research has really helped me on having a mindset, which is super helpful in my own career growth, is to be able to be ready for trials and errors. There are a lot of times we just need to keep iterating. It's never the perfect solution, but we build a 60% good, 80% good, and keep iterating on that. And also having the perseverance. Sometimes things are not just working as expected, especially when we're doing some experimentation. It can be just taking some risk, and we just try to figure something out by keep trying new ways of solving the problem. And let me check on the time. I think we're good. So that's on how I feel biostats has really helped me in my career journey. In the last slide, I also want to share a few tips on how LinkedIn can help you in building up your career. I am a job seeker recently, so I just use my dogfooding my own product for a lot of things. And I feel there are 3 things that really help in landing a job or finding new opportunities. The first one is building up a profile by listing the education, projects, the skills you're proficient with and familiar with. Basically, the profile is like a knock on the door. Second thing is reaching out to people. I think Dave and Lai both mentioned building connections and reaching out to people. That helped me got my internship as well. And I feel by just reaching out to people on LinkedIn, although the reply rate may not be super high, but you'll be surprised how kind people are in offering time to share informational chat with you and share their own day-to-day work in their industry, in their company. You may learn a lot of information before making a decision or even considering joining a company. And the last thing is leveraging the job portal. There are some preferences you can set to create a open job alert. When a new opportunity comes up, you can get a notification through email, and also turning on open to work when you're ready. This will let the recruiters know you are in the market so they can reach out to you and by surfacing opportunities to you directly in your email. And those are the few things, and I hope to leave enough time for everybody to ask questions, although I know we're about time. Thank you again for staying here and listening, and let's stay connected over email and LinkedIn. Feel free to reach out.
All right. Thank you very much, Ying. That was excellent. So I'll just follow up on the last thing about LinkedIn is we do have a USC Division of Biostats group as well. So please feel free to join that or send a message to me if you want to join that. Some of the notifications of getting people on that don't necessarily send it to their email. Anyways, any questions before I start asking? So, trying to see in the audience.
Can I ask a question? Oh, sorry.
Yeah.
We have one in the room.
Okay.
Go ahead.
Hi, Ying. Thank you so much for sharing. I'm wondering, can you share more about the difference between data scientist and a machine learning engineer in your career?
Yeah, thanks for the question. You were asking about the difference between those two job functions?
Yes.
Yeah, I think they are very similar, to be honest. A lot of things, core skills are pretty transferable between a data scientist and a machine learning engineer. I would say the key difference would be data scientists are owning product strategy. They're owning using insights to drive decision making. And also, like Lai mentioned, there can be very heavy stats framework to do for experimentation. For machine learning engineer, it's more on building models that are productionized in the system. They're owning the code base, the machine learning system that are powering different products like recommendation products, search product, fraud detection, advertising, etc. Does that answer your question?
Yes, thank you.
So Ying, following up on that, do you think that a PhD in biostatistics has separated you from like your colleagues or others to give you a special niche?
It really depends on the project. If a project is very stats heavy, for example, like the two ones that I shared in the slides, that really sets me apart. There are also many other projects which are not super stats heavy. For those projects, I don't think they really care about your background, whether you're a PhD or not, whether you're undergrad or even going to grad school, what is your thesis about. They just care about whether you can build a solution to solve the problem. So the problem solving mindset is really critical in the career.
Great. Any other questions?
I have a question. In either of your positions, are you proposing the problems to be solved, or are you mainly solving problems that others pose to you?
Yeah, that is a great question. In my early career, the first 1 to 2 years, I think I'm mainly just taking whatever that's given to me as a question, as a problem, and they pose it as, this is important to solve, but not always the case, to be honest. So I would say use your own judgment on what the problem you are solving. Is it really worth your time to do it? But later on, as I become more senior, I start to propose what to work on because I can use the context I gather from the partners to know what is really important for the business. I can do the opportunity sizing myself as a data person, and I can run those proposals through stakeholders and see this is the potential gain we can get if we can solve this or that. So by proposing questions, I think that opens a new area for me to expand my scope and also be able to get exposed to a bigger picture and also understanding what are other people thinking by connecting with colleagues in different teams. So I would say building connections at the workplace is also important for making an impact.
Great, thank you. Any other questions? If not, I would like to, again, thank Ying and Lai Again, we have awesome alumni. We have awesome current students as well. So this is just an indicator of that. So go out and do great things, everybody. We'll see you in a couple weeks for the next Biostat seminar. Ying Lai, thank you very much.
Thank you. Thank you for having us.
That was wonderful.
Thank you.